Okay, 20, yeah, 24, 25. Lesson 10. Is that right?
Yes,
More elimination. Now, I don't know how much of this you need, but I'm going to do it for the video. So I'm going to go back. I'll go ahead and get my heading. We're pretty much through with solving systems algebraically. We're going to do the the ACT part of it next Thursday. And it'll probably take us 2 lessons because even though I don't think we have a quiz that day, it's going to be hard to try to get it all in because I need to load a program on your calculator, and then we'll do the notes, and it's like 5 word problems that we're going to do in the notes, and they're just time consuming. Oops, forgot my page number, 24. Lesson 10, more elimination. Now, just to review, we've had systems. Quiz today was solving systems by graphing. They're either going to cross at a point, they're going to be parallel with no solution, or same line with infinite solutions. We did it in 7 and 8. We did it by substitution. And we'll do 1 quiz over that. We did elimination in 9. We're going to finish it up in 10 today, and we'll do 1 quiz over that. Elimination is the idea of adding to get one of your variables to go away. We love it if they're already lined up, ready to add. In this case, you only had to multiply 1 of them, and today all 6 of them will be, you got to multiply both of them. They're still pretty fast. So we're going to do 3x plus 5y equals negative 25. And we're going to do negative 4x plus 3y equals 14. Now your special cases, I think of the 6 you have in classwork, you have 4 of them that will be like this one, where it'll have a point of intersection. 1 will be no solutions, and 1 will be infinite solutions. But what happens here, if we want the variables to go away, then we would have to have 12, 12. One of them have to be positive, one of them negative. Or we'd have to have, and we'll put 12 up there. Or we'd have to have 15 and negative 15, and we'll put that up there. Now you can choose either one of these, but I'm going to tell you why I like the X is better, because the signs are already there. To me, if the signs are already there, it makes it a little bit easier, because all I have to do is make this one a 12 and this one a negative 12. So what would I have to multiply this one by to get it to 12, positive 12? 4. So I've got 12x plus 20y equals negative 100. And then what do I have to multiply on this one? It already has the negative. No, now if you do negative 3, right, see the negative's already there. So, because if you have to multiply by negative, sometimes you'll miss your signs as you go across. If you'd done the y's, you would have had to do one of them positive, one negative. But I like it. I would always choose if there's one of them that has one positive, one negative. To me, those are the easiest. Plus 9y equals 42. Now we can add. Only the x's go away, so we know they're going to cross. And we get 29y equals negative 58. Divide by 29. All of these two come out even. And you get y is equal to negative 2. So I'm going to go over here and set my answer up as we need x and y, and we know the y is negative 2. Now look, you can put the y in 4 places. Now I don't know that I would ever choose these. The only reason I might over here is if maybe these two had decimals or fractions in them. We don't see that much in regular Algebra 2. Really, we don't see them in either Algebra 2 much. That's more bridge math, college algebra. So I would use one of these two. Put the y either here or here and substitute, get back the x. Which one do you think looks the easiest? Yeah, and you know, one class will choose one will choose the other. Last class said just choose one because they're both about the same. So you said the top one? Okay, so let's put the negative 2 right here. And I'm going to show it, so at least if you have to go back to your notes, you'll know. 3x plus 5 times, that page does not want to stay up, times negative 2 equals negative 25. 3x minus 10 equals negative 25. Add 10. 3x equals negative 15. So what's x?
Negative 5.
Oop, almost divided by negative there. 3, and we get x equals negative 5. And you can check them back in. Those both work. That's where they intersect.